All right, good morning, guys. We are on lesson 10, designing experiments this morning, page 79. The first questions there say find the value mentally. So you could add these up. 4.2 plus 7.2, or plus 3, excuse me, is 7.2. Half of 7.2 is 3.6. The other thing you could have done is taken half of 4.2, which is 2.1, half of 3, and then added them together to get 3.6. It doesn't really matter, but whatever strategy you use, I don't care what strategy you use, you'll notice the answers are all the same. Okay, you get 3.6 for all of them. Question number 2, a scientist is studying the genes that determine the color of a mouse's fur. When two mice with brown fur breed, there's a 25% chance that the baby will have white fur. For the experiment to continue, scientists needs at least 2 of 5 babies to have white fur. So 25% chance, we got to find something with a 25% chance in order to design this experiment. And what I chose was flipping coins, because if I flip coins, I get heads or tails, right? And I flip it again, get heads or tails. That's a total of 4 choices. I could get heads, 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 tails, tails, heads, and tails, tails. So I would just choose one of those options to be the 25% chance of having white fur. So I chose 2 heads. Okay, so if I flip 2 coins and I get 2 heads, and you can do your own experiment. Okay, you can do your own experiment. Looks like we're doing 5 trials, or 5 times each trial, and we're looking for at least 2 or more times that this will happen. Okay, so I already did it on the next page. I did 3 simulations, and the Y represents yes, it came up heads, heads, which means it has white fur, so I'll make a little note. And no means it still has brown fur. Okay, so I did it a total of 15 times, 3 simulations of representing 5 mice being born. And do I have at least 2 with white fur? I do not, I do not, I do not. So it did not happen for me at all. Based on the results, estimate the probability that the scientist experiment will be able to continue. So based on my results, I'm going to say it's not going to be able to continue because I never got 2 or more white fur in all my trials. Again, you could do your own trial flipping coins and then put your own data in here. How can you improve your estimate? Obviously, that answer is always the same. Okay, run more trials to get it more accurate. 3 doesn't really give you a lot of leeway if the cards or coins, if you will, do not fall in your favor. Okay, for a certain pair of mice, the genetics show that the offspring has a probability of 1/16 to be albino. Okay, so now instead of 1/2, we're looking at 1/16, and albino would mean completely white. Okay, describe a simulation. So we need a simulation that would represent 1 out of 16. Okay, so I got to think of something that has 16 results, and again, I'm going to stick with the coins. 2 coins were a result of 4. 3 coins would be 8, 2 times 2 times 2, and 4 coins would be a total of 16. So I would design flipping 4 coins, and then you could do a tree diagram like we did on the previous page. There represents coin 2. Coin 3, there's your 8 results. And we could go again for the represent the 4th coin. And I'm going to let you just continue to fill that out. And you're going to get 16 results, and I would just choose one of them to be represent albino. So I usually just take the top one. So if I would get 4 heads on all 4 coins, that would represent albino. Again, not very likely, 1 out of 16. Okay. Next page, it says your teacher will give you a couple situations, and you have to design an experiment, a simulation, to represent that. So I'm just going to show you a couple of examples. Okay, a man has 5 grandchildren, 4 boys, 4 girls, and 1 boy. He thinks that's very unusual. If the probability that any child born will be a girl is 1/2, what's the probability that a person who has 5 grandchildren will have exactly 4 granddaughters? Is this case unusual, and explain? Okay, so we got 5 people, and there's a half chance, boy or girl, right? So again, I think the easiest is to choose coins when we can. So on this one, I would say we're going to flip 5 coins. Let's say heads represents girl, and tail represents boy. Okay, so you're flipping all the coins. Okay, so what is the probability that he will have exactly 4 grandchildren? That means when I flip it, I would end up with 4 H's, which represents girls, and a tail, which represents a boy. Now, any order that those come in are fine, right? It could go girl, boy, boy, girl, boy, girl, 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 so on. So it doesn't really matter. So when you're making if you'd make a tree diagram, you could find the exact probability. We have 5 coins, so if you'd multiply 2 times 2 times 2 times 2 times 2, you'd have 32 choices. And if you would show all the possible outcomes, 5 of them represent 4 girls. Okay, 5 represent 4 girls. Okay, so let's see. Design an experiment. Okay, so I came up with my strategy, and how many times do you think we would have to flip that to show a good outcome? Let's say we did it 20 times. A good experiment. Okay, so we designed it, we talked about the coins, what represents what, and we said we're going to do it 20 times. Okay, let's try one more. Okay, automobile factory, I'll just cover this other one up. Has a reputation for assembly high quality cars. Several new cars were shipped out of dealers that have a problem with the brakes. It's estimated that approximately 10% of the cars assembled have defective brakes. So 10%. 5 of the cars are shipped near the school. It's probability that none of the 5 cars will have effective brakes. So first of all, I got to represent something that represents 10%. Okay, so I can't use a coin, that's 50%. A dice is 1 out of 6. So let's say I use 10 slips of paper. One slip is black, and 9 slips are white. Okay, so 10 slips of paper, 1 is black, 9 is white. So if you draw a black slip of paper, that means your brakes do not work, because you have a 10% chance of getting faulty brakes. To me, that's not a very good dealership if 10% of your brakes don't work. Okay, so drawing out of 10 slips of paper, 1 black and 9 are white. Black, of course, would represent defective brakes. Okay, so again, how many times do you think we need to do this? Okay, should we do it 20 times again? That seems like a good number. And it looks like they're shipping 5 cars. So I'm going to draw 5 slips of paper. What is the probability that none of the cars will have defective brakes? So if I don't want any of the cars to have defective brakes, I would get all white. So that's my goal, to get all white slips, which means working brakes. So my experiment would consist of the pieces of paper. I'm going to draw 5 slips out to represent the 5 cars, and I'm going to do that 20 times. So I'm going to draw 5 slips, put them back in. Draw 5 slips, put them back in 20 times. And this is what I am looking for. And that's what I'm looking for. And again, we said 20 times. Want to be more accurate? You can always do more trials. Okay, the summary there points out that real-world situations are difficult to repeat enough times to get an estimate, okay, because we could probably do that 150 times, okay. or 200 times, or probably design an experiment on a computer program that would do it like 120,000 times. Okay, because you won't want to draw that many slips of paper. Okay, so the easier you make it, the easier it is to repeat. And it talks about some of that on the next page as well, on page 82. Your assignment, guys, page 83 to 85, 4 questions for homework. Hope you guys are continuing to stay safe and healthy, and we will talk to you soon. Bye-bye.